Got an interesting one for you guys today. We're going to be discussing some of the comments you left. Buckle in. Hey, what's up guys? My name is Cherno. Welcome back to, I don't know, I guess this is part of the code review series. This is just like talking about C++ and programming and code. It's just my channel. Welcome back to my channel. You'll probably hear I'm still a little bit sick, still recovering, so I apologize for my voice. But the last couple of videos, we've been focusing on some code that one of you sent in of this pretty cool, like real-time air traffic control game. And I, of course, like to use these real-world, like actual real projects that you have developed as kind of examples, you know, just as like a subject, a model, if you will, for us to be able to discuss the code and for me to share my humble thoughts and opinions that will hopefully help some of you out. Now, I'll have the videos, there's two of them. I'll have them linked up there and in the description as well if you want to check them out. But one of the things that author wrote was this kind of design pattern, I guess, called a singleton. And if we're being really specific, it's a specific like version of a singleton called Meyers singleton. I'll leave a link in the description below with more information about that specifically. Now, I didn't like it. I specifically didn't like it in that case, and I talked about it, and I also shared a solution that in my opinion would have been a lot better for that specific use case, and I kind of called it using a global variable instead of a singleton. And I think that's where I lost a lot of people. You know, I can tell by the comments. And this is kind of what I want to do more of. I want to look at your comments. I want to read your comments that point out that maybe I'm wrong in one case, or maybe I just did a poor job of explaining myself. And I want to actually take the time to dive deep into that area and spend a little bit more time discussing these topics, because I think that as a community, that's hopefully how we all get better. We spend time going back and forth and we learn. So before we take a look at this specific comment here and dive deeper into what exactly I meant when I said globals are better than singletons, because yes, at face value, that sounds a bit weird. Something that I feel can greatly supplement your learning is Brilliant.org, the sponsor of this video. Now, for those of you who don't know, Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. The name of the game with Brilliant is visual learning, interactive learning, and engaging learning. There's none of this like watching videos, zoning out, not being asked to do anything. It's all about you jumping in, looking at the stuff visually, playing with like widgets to see how numbers change things, and being constantly quizzed to make sure that you're actually learning and retaining this information. Now, talking about specific courses that Brilliant.org offers, I really like their introductory computer science courses, because rather than just focusing on actual code, they focus more on teaching you how to think like a programmer, which, to be honest, is, you know, should be the first step. But again, visually and interactively, so you can like drag all of these things around to determine the flow of your program. And once you gain confidence here, you can take this to the next level by actually using a real programming language like Python instead. But then the elephant in the room when it comes to programming is math. You just need to know math. Like, love it or hate it, math is really, really important. If you're an absolute beginner, then Brilliant has this everyday math course that will give you a really nice, gentle introduction. But then you can progress forward onto things like geometry, algebra, linear algebra, calculus. Again, with all of these widgets you can play with, quizzes, it's such a fun and effective way to learn. And Brilliant have a 30-day free trial that you can use to try out all of the courses that they offer on their platform. Just go to brilliant.org/thecherno, link will be in the description below. Huge thank you, as always, to Brilliant.org for sponsoring this video. Okay, so this comment, let's take a look at it. You are wrong about the singleton via instance functions being unusual or not useful. It is a fairly common pattern in C++ code known as Meyers singleton, which avoids certain issues with global objects, namely the static initialization order fiasco. Furthermore, since C++ 11, it guarantees the initialization happens in a thread-safe manner the first time the function is called. Among others, the C++ core guidelines recommend this version if you need a singleton at all, which I agree you rarely do. Now, there's a bunch of replies here, including people saying I'm not wrong. Thank you. But then also Code Matters follows up with, I'm not saying singleton is great. I personally consider it an anti-pattern as well. But if you want a singleton, the way it was done in the code, which was the Meyers singleton, is a well-known, common, and reasonable way to provide it. And 147 people agreed with this comment. So let's talk about it. Let's talk about why this probably isn't quite what I meant. And let's kind of expand on the situation and talk about like this specific version of singletons in general. Why specifically did I not like the way that the code was done? Why do I and a lot of other programmers tend to avoid singletons in general? And all of the, but what about that will go along with this as well. So the first thing I want to mention is the specific example that we were taking a look at. This is it in the original code that's on GitHub. I'll have a link to this in the description below. This is the singleton that through the instance function created this instance of resources manager in static storage, which again is, I guess, formally known as Meyers singleton, and then featured a bunch of like resource manager related functions and functionality, as well as like some other stuff that really shouldn't have been in here. So context. Context is very important. This is a resource manager. In my opinion, a resource manager is quite a fundamental application system. To put it one way, it's basically responsible for like all of the external files and resources that our application will not only load, but also manage things like memory, which of course is very important, manage things like the loading of a resource when it's required, and also unloading the resource when it's no longer required. As an important application system, I don't think that it should be initialized at an undefined place or time within our application. And then also, because it lives in static storage, being shut down, being deleted at the end of our entire program, when our program terminates. I personally would much rather prefer, again, for a resource manager, for an important application system, I would much rather have a very well-defined initialization and shutdown. There are many reasons for this, and also a lot of caveats as well. One reason might be dependencies. You might not be able to load a texture until your graphics rendering API, such as Vulkan, is initialized. And you might have to release that texture from GPU memory before trying to shut down your Vulkan device, otherwise it will yell at you. And we don't like to be yelled at. One caveat might be, but I'm not using the class instance initialization and shutdown itself as the actual system initialization and shutdown. And this is where things can get a little bit murky, a little bit weird. What I mean by that is your class could simply just be memory, right? The reason why we might have a class instance of this resource manager class is just because we want like, let's see what's in here, like unordered map, vector, just a bunch of like maps, vectors, other variables. We might want this memory just present, allocated, initialized, and that might be the only function of having a constructor and initializing this class instance. But then we might have an actual explicit function inside this class called init and shutdown. And that is the thing that would actually, perform the initialization and shutdown of the system that might have those prerequisites or dependencies. In that case, by having that explicit init and shutdown, you obviously get around this undefined initialization of the class, because whilst the class might be instantiated at who knows when in your program, all that is a memory allocation, and it has nothing to do with actual work being done to initialize resources or other systems or use the graphics driver or whatever it may be. Now, I keep saying undefined. Let me just clarify that. What I mean by that is we don't really have that much control over when the class is instantiated. And the reason why is because the first time you call this instance function is the first time you run through this code and therefore actually instantiate this class in static storage. The idea behind this, and one of the reasons why this kind of singleton works so well in some cases, is that you never have to worry about that explicit initialization or instantiation. You simply just use it at some point in your program, wherever that may be, and if it hasn't been created yet, it will be created. If it has, you've got the instance and you'll simply use that, which is obviously very convenient. That's the whole reason why it exists. And again, it has its use cases, but just not for this, in my opinion. Another term for this kind of, like design pattern or whatever it's called, is lazy loading. It's basically the idea of, instead of, again, explicitly specifying when you want something to load or become available or initialize, you're just letting the first use of that thing dictate its initialization. So you're kind of just deferring that initialization until the moment that that thing is needed for the first time, which again, for many things is great and really convenient, but for other things could be devastating. Like for example, if you needed to load an asset in a game. Let's just say you've made a game, it's a 3D game, you have a character and they can launch a rocket. They've got this like rocket launcher weapon, and when they fire, it just launches like this rocket. Now to launch that rocket, you need to load the 3D model that is the rocket, along with all of the materials, all of the textures, everything that goes along with that actual physical rocket mesh. If you decide to lazy load that, so defer the loading until it's actually needed, then as soon as the player actually fires that weapon, you now need to trigger the loading of the mesh, the materials, the textures, all of that stuff. And that, of course, takes time. So one of two things will happen. Either the game will just freeze for like, I don't know, could be like a few frames, just drop a few frames, just freeze while it loads all of that stuff. Or it does it asynchronously on a background thread and you just see a placeholder or nothing at all until finally, a few frames into the future, you see, oh, the rocket popped in and it's flying away. Both of those scenarios could be avoided if you just preloaded the rocket, if you just loaded the level or loaded the map or loaded the game, whatever, and you were like, okay, well, I'm gonna need the rocket at some point, most likely, so let me just have that ready to go loaded so that I don't have to trigger a load the first time it's actually used. This, of course, is a completely different scenario, but I just wanted to illustrate how lazy loading, as great as it sounds, can sometimes actually be pretty bad. Okay, so now that we've hopefully clarified in this comment that I'm specifically talking about because this is an important core kind of system to this application, let's talk about singletons in general, which again, this person does actually consider it an anti-pattern. So they're not on board the single train, I meant to say like singleton hype train. And there is slightly more to discuss here as well, but I just want to talk about singletons in general and why so many programmers avoid them. Like, why do I not want to use a singleton? It sounds great, right? So the reason why singletons are bad is because they just magically exist globally and they're accessible from anywhere. The thing is, those might sound like pros. They might sound like advantages. Why wouldn't you want something to just magically exist everywhere, be accessible, and I can just use it whenever I need it? I don't have to worry about anything. The reason why that often isn't as good as it seems is because in programming, we generally like to tie things together. I think a good way to think of this is kind of like you have a tree. You have like this tree of all of your different like objects or, I don't know, systems, entities, functionalities, all kind of stemming down like a tree. The reason why is because this greatly simplifies many complex topics such as lifetime and ownership. Let's say, for example, at the top of the tree, we have our application. This is our application class. That's kind of the root of our application. And an application might have many different things, such as a window or a layer system with many layers. The window system in turn might have like a graphics context, an event system, an input system. Over in our layer system, we might have our game layer, which might have, I don't know, our game data, a resource manager, whatever it might be. This is just meant to be an example. If we decide that we need to, I don't know, restart the window for whatever reason, then we can simply drop the window and then make a new one. And as you can see, when we drop the window, everything that belongs to the window, all of these systems that clearly stem from the window are also automatically dropped and then recreated. Or maybe our game layer changes to a different game layer because maybe our layer system is tied in with different levels or worlds or scenes inside our game. So then by destroying our game layer, we also release all of the resources that are associated with it and all of the game data. And then finally, at the root of it all, our application, if we shut down our application, then everything else shuts down. Could you imagine if these were all singletons? Like the input system could be a singleton, for example. The resource manager could also be a singleton like it is in this very example. So then now what do I have to do differently? Well, if I want to drop something like the window or the game layer, I kind of have to manually shut down the input system and the resource manager. But then also, what about initializing it? See, when it's a tree, I know that my window will be initialized first, and then because the input system is part of the window, it will be also initialized as part of the Windows initialization. Same with the game layer and the resource manager. Once the game layer is up and running, it will initialize the resource manager and everything just works. This, I think, is so important in programming. And I think especially so in a language like C++, because there's no garbage collector. There's no just like, oh, well, it doesn't matter if I stop using that object, eventually it'll get deleted and the memory will be freed. No, you have to be very explicit about how things work. That's why, if I'm being super clear and I wanted to rewrite this original code review code, properly, then yeah, I'd probably set it up something like that tree that I showed where we just have the resource manager stemming from some other system, maybe like the project context, which would be like the game context or something like that. Because the resources, the assets after all, are of course related to that specific game. However, and there is a big however, the advantage of singletons, as I mentioned, is simplicity. Setting up something like this tree, to be honest, wouldn't be that difficult. But even easier is not caring about any of this and just having like a class instance with data associated with it, with memory, right, associated with it, with storage, that you can just access anywhere. Because the other thing is you have to provide a means for this input handler that's, part of the window here to be accessible by, say, the game layer, because maybe it wants to, it probably almost definitely wants to react to keys being pressed or the mouse being moved. You have to provide all of that infrastructure, all of this kind of like scaffolding that lets you access what needs to be accessed. It's not even scaffolding, to be honest. It's just like the core kind of construction of your application. With a singleton, you can just be like, lol, this is just global. I can access this from anywhere. It'll probably work. Let's just do that, right? And to be fair, that is viable sometimes, especially for really small projects where, again, this might be a little bit overkill. You can't engineer everything like a AAA game engine or some really complex application, because it just doesn't make sense in a lot of cases. And again, in so many cases, there might not be any perceived benefit from that. So then in my view, there's this concept of like, well, can we find a middle ground? And that's where I mentioned that simply having a global variable is better and more C++y than having the instance redirection for really no reason. And I guess this is the core of CodeMeta's comment, the original comment, and the way that they understood it. So let me share with you what I meant by that, because yes, in retrospect, calling it like a global variable is a little bit weird. And also in my mind, it's kind of 2 steps forward from the original, Meyers singleton that was written. So over here in Visual Studio, I have a singleton. I've written this like singleton system over here. I've called the actual class system because it's supposed to represent some sort of system. So over here we have a getInstance function, which kind of has 2 ways of creating this system instance. There's this like stack way, which again is not actually like on the stack, it's in static storage, but it's still kind of stacky in the sense that like it's not a heap allocation. And then we have a heap allocation, which, I guess I can't really recommend. And the reason why is because this will never really be freed. I mean, it can be. You can explicitly delete this instance at some point in time, but this being in static storage and also like a pointer that we manually called new on to allocate on the heap would mean that it would never be automatically destroyed. You could obviously change this to be like a unique pointer and then just return the actual like unique pointer.get to return the raw pointer from that, or you can make it a shared pointer, just use shared pointers everywhere, kind of defeats the purpose as well potentially. So what I've done over here, and then, I've written this kind of do work function, which I forgot to fill in, which is just supposed to, emulate us doing some kind of work. So over here in the constructor, I have singleton constructor being printed, and in the destructor, singleton destructor being printed, just so that we can see when these actually run. And over here in our main function, I've just got hello and goodbye at the start and end of our main function. And then within this scope here, we're going to use the singleton system, and we're just going to call, get instance do work. Let's see what happens with that. As you can see here, hello is the first thing we print, then singleton constructor when we call get instance, then goodbye gets called, and then after our main function terminates, that's when static shutdown is. So that static storage duration object gets destroyed here, which again is likely unacceptable in a lot of cases, especially if you're actually doing stuff in the constructor and destructor. If you're not, if you just have this init and shutdown function that do all the work, then none of this applies. But the way that I'm treating this is that the constructor is used to actually instantiate things, and the destructor is used to destroy things. And the reason why, I think, because a lot of people would argue that, okay, constructor maybe don't do initialization there, maybe have an explicit init function, whatever it may be, I don't care. The problem is that you can't really say the same about the destructor, because if inside this system you actually have stuff here, such as, for example, a vector of, let's just say, I'll just make these shared, could be a raw pointer, I don't care. The point is you might have like some actual textures in here that are stored like this inside a vector, inside this class instance. Sure, you might not have to initialize them in the constructor. You could have some function called load or init, or explicit functions called like load texture with a path that loads these individual textures. They're not going to get destroyed until the destructor, because this vector object resides inside this class, right? So it's just a class member that is, no matter what, going to get destroyed at the time of the destructor being called, after the destructor is called, technically. So then in this scenario, you're still stuck with everything else in your program terminating, except for the static storage duration objects being called after the main function, which again would be unacceptable in a lot of cases. So the first level of combating this is just to rewrite this slightly so that again, you're not doing this lazy loading. Instead of doing this like Meyers Singleton situation, you explicitly initialize it. So if we just take this and rewrite it slightly, what we suddenly need to do is somehow store this somewhere. And there's actually a way that we can do this whilst still storing the pointer itself in static storage, which is a little bit weird. So what we can do is we can actually leave this as is for the reason that I mentioned, that now what's going to happen is that the first time we run this, it's actually going to create, obviously, a new instance of the system on the heap. But the difference is that the destructor of system is only going to get called when we explicitly delete it. So it's like we've kept the lazy loading, the lazy initialization being done the first time get instance is called, but now deleting it has to happen explicitly. And the way that we can make that work is by just having a function here called shutdown. And I'll make this a static function. So now inside the shutdown function, we can call get instance because that gives us the system reference, but we know that at the memory address of that, obviously is the pointer that we're trying to call delete on. So we can do something like this, which of course looks very weird, but if we go back to main, then when we are done with our system and we want to explicitly shut it down, we can do something like this. And as you can see, that's shifted this up now. So this now happens together. Again, the constructor happens the first time get instance is called. So wherever your system is used, wherever the singleton is used for the first time, magic, but then the shutdown is explicit and before we actually say goodbye to our program. A better way would probably be just to not store this like this, static in static storage, the pointer itself, I mean. You can obviously take this, put it as like a static inline system s instance or something equals null pointer over here into your header file. I'm not sure why this is a non-static data member cannot be stored. It is static. Okay, whatever, we'll ignore that for now. So now this disappears. Note that this is obviously still null though. So the first time we run this, let me get rid of this comment, we now do if null s instance equals new system, and then we return dereference s instance. Inline variables require at least C++17. How am I not on C++17? On the odd chance that you guys are somehow using a version that is below C++17, by the way, which of course I thought I was on, thought I was probably on C++20 with this project, apparently not. You won't be able to do static inline, so you'll have to do something like this. You won't be able to set it here, and then this is just some, blast from the past C++, and then you would have the type here, the namespace, and then equals null pointer. You would do this over here inside your C++ file, inside your CPP file. And then over here, you just have that. And that, would work as expected. But now that we have C++17, which if I go into the project settings, I'm using C++14 apparently. Whatever, let's just go to 20. You don't need to have this, which is, yes, annoying because you're kind of duplicating your code. And we'll just have static inline or inline static, doesn't matter. System S instance, and then we can assign it immediately, right? So that now means, again, shutdown, we don't have to do anything like this. We can just do S instance, but more importantly, we can actually set S instance to null pointer just to prevent potential errors in the future, just make debugging easier. We'll see if it's not initialized because it's null. And that, of course, if we run it, is just an alternative to what we looked at before. Now, if we didn't want lazy loading, then I'm sure you could figure it out. We would just have a function called init that would do this. So instead of us doing this the first time that this runs, we do it explicitly by calling a function called init, which just does this line over here. Now, I will note that an advantage of doing it this way, apart from like the explicit shutdown, potentially explicit initialization, whatever it may be, is that this is compatible with languages like Java and C#. You can't really have like the static storage method that we did in C++, that's C++ only. And also what I'm about to show you with the global variable, that also is C++ only. Well, not C++ only, but you can't do it in C# or Java. This is compatible with C# and Java. So this is a nice kind of compatible way that you can really achieve this like in any language, because all you really need is just the ability to have like a static variable. If you can have a static variable, you can have this kind of singleton. So now finally, let's look at the global situation. What did I mean by global? And what I meant by global was just taking this one step further because we are in C++ and we don't have to pollute specifically the header file of this class with this variable. You just don't need to, because there's no advantage to this being a static variable inside the system class. We can just have this be either a global variable or a global, it's not really global anymore, variable with internal linkage, meaning a static variable, but it's not in the class, it's inside the CPP file. So that's what I meant when I said global. And if we take a look at this global version, you can see that there is no mention of a system pointer static variable in here. And instead what we have is this inside the CPP file. I've put this little comment here because static is optional. Usually I would actually have this. And by the way, for those of you who don't know, the difference is if you make this variable static, then it's kind of like you're making it private to this specific translation unit, to this specific CPP file, meaning you won't be able to access or see this variable from another CPP file. It's locked to this one. So it's not really a global variable. It's just a variable that is just accessible throughout this specific file. But of course, it's still a pointer that we can return from a function. If you don't make this static, then you're saying that this is global, meaning that if I, take this into main.cpp and I just write something like extern system instance, obviously inside that namespace and everything, then suddenly I can just use this variable. I can change this variable. I can do whatever I want. It's a global variable. I probably wouldn't recommend that unless you know what you're doing. Again, for core level systems, that's actually a common way that people do write code. People do make things like resource managers global because they should be globally accessible. The only big problem that I see with this is that you could, it's not just read only. You could write to it. You could set it to null pointer. I don't know why you would. Again, a lot of this relies on people, for some reason, misusing the code, which I guess it's always a good idea to give people less ways that they might accidentally, some intern might be like, oh yeah, deinitialize, shut down the system by just writing null pointer. That's how the author intended this to be used. Of course, this is all I know. No, that's not, no one really would do that, but I guess I agree that less potential margin for error or whatever is probably a good thing. So I would make this static, initialize to null, but then you call init. And I've got some asserts in here just to make this a little bit more robust. I use asserts all the time, not specifically this included assert function with C++, but in Hazel, we have in any code base really that's bigger than like a little sandbox project. I have like an assert system that will log to a file, potentially bring up dialog boxes, work in certain ways, in certain build configurations, get stripped from distribution builds, that kind of thing. I think that's very, very important. Maybe I should make a video talking about that in the future. But you can see we have an explicit init here, which just creates the system. We have an explicit shutdown, which deletes the system and sets it to null pointer. And we have get instance, which will assert to make sure that it has been initialized first, since now that is explicit. So you have to make sure it's done, and it will return it. So if we go back to main and we just change the namespace over here to global, if we try and run it with the exact same code, that's not gonna work, right? Our assert's gonna trigger because S instance is null. And of course, the reason for that is because we need to have that explicit initialization. We explicitly initialize our system, then we can access it globally and do whatever we want with it, and then we shut it down. And this, of course, works in the exact same way. So that is what I meant by global variable. Yes, poor choice of words. It's not even a global variable in the first place, and it's still a singleton that still works the same way. The only difference really is that I am now controlling explicitly the lifetime and the exact point in my program when it gets created or initialized, and the exact point in my program when it gets shut down, as opposed to the static storage, which is a little bit, it is still kind of defined, on a per use case basis. It's the shutdown, I think, that really is a thing that I don't like about it. But with this being C++ specifically is why I would do something like this rather than just having a static variable in the class like you would need to do in Java or C#. So hopefully Code Matters 1284 and everyone else, hopefully that clears up what I meant by global variable over a singleton. But crucially, I hope that you now also understand why ideally we wouldn't be using singletons at all in this case. The only reason to use them here is because this is a small project, it's a small game. I just want my resources to be accessible, man. That's all I want. Is that too much to ask for? I'll just use a singleton rather than architecting your software properly by having something like that tree that I mentioned earlier, which is without a doubt more robust. And of course you can make it work the same way in terms of like when you're done with it, you can access the data you need, you can access the resources or trigger loads or do whatever you need to do. It's just that the architecture is more robust. I hope you guys enjoy this video. Let me know if you want to see more videos like this in the future. If you have any topics that you want me to do a bit of a deep dive like I did with this one on, leave a comment in the comment section below, and I will see you guys next time. Goodbye.